see, Zaid is looking after me even here. One thing about Zaid though, everybody said Zaid is our brother. But Zaid is my brother too, so that makes me your brother. So we have to make sure that Zaid is our brother. Okay, so let's continue with our second presentation. Yes, go ahead.
Please, if we have one building, we have pressure from the front area, and we have pressure from the side area, and we have pressure on the roof and rear. When we design any building, we take it all in one case.
Okay, that's another very good question. So it depends as a structural engineer, what is your purpose? If you want to protect your building, the highest one will be the front wall. Okay, so but then you may have a glass on the side, you may have a concrete wall in the front, and you may feel that concrete is good enough and you want to look at sides. Sure, you do that. But if front and sides have same strength, then it is sufficient to do only the front load analysis, because there you have very high pressure, right? But if you're designing your beams that may be supporting your roof, then of course you need to know roof pressure. So typically you do front, side, and roof. Rear wall is usually not done unless you have a good reason, because it helps you, right? So you push the structure that way, and rear pressure is helping you. And people usually don't do rear. It's acting in the other direction. And by the time shock wave travel passes the building all the way, go to the back of the building, the magnitude diminishes quite significantly. So this is a long answer to a short question, but you have the option of analyzing all sides, but typically people concentrate on front of the building because that's where you have the highest pressure. Any other question?
Yeah.
Yes.
Actually, I've spoke about external bombing. What if it happens in basement, as you have stated before? Inside the building itself, there is no distance over there. You have zero distance.
Okay. I was avoiding that because it's a complex problem. If you have close-in explosion, or if you have contact charge, in fact I have a topic to give a lecture on that, it's completely different, right? So then the shock wave has not had a chance to form, because you need some distance, and that distance has to be equal to radius of the shock wave, which we haven't discussed in detail. So when shock wave forms, and it takes probably 5 meters to form, and then it starts going as a big wall of pressure. So if you have a building within that 5 meters, then it hasn't it hasn't fully formed, and then what happens is that you're in that excessive heat, excessive pressure zone. It starts causing material failure. It causes, I have a slide to show, it starts scabbing, it starts spalling concrete. Effect on material is more intense than the effect of member. Okay, this is called close-in solutions, close-in explosions. But the curves that I showed you, the US Army curves, do not apply to contact charge and close-in explosions. The problem becomes very complicated. You have to use software like Elastina or ANSYS to do competition fluid dynamics. And even there are challenges. How do you model material? They have their own materials. You have to trust them. Yes, but that's a different problem and more challenging problem. But perhaps the important answer to your question is it affects material rather than member. Any other question? Okay, so with that, we will now look at building standards and building codes and what do they do. I will give Canadian standard as an example, but as I said earlier in my introductory remarks, it is applicable to American ASC standard.